Let's give it up for Mr. Raghu Kalidindi, Managing Director, Akrivia Automation. Can we have Mr. Raghu on stage with us?
All right. Yeah. Well,
Raghu sir, the trend at Exito, by now you must have anticipated a very interesting question for yourself. So the question to you is, ladies and gentlemen, Mr. Raghu right here is a master of research and development with nearly 30 decades. Oh my God, 3 decades, 30 years of experience in the same. Sir, so our question to you is, how has doing R&D professionally helped you solve real world life problems? Because by now, you are so data oriented that any problem that comes in, I'm sure you come up with an algorithm and permutation and combination of all the outcomes as well.
Yeah, thank you. Very good afternoon to all of you. To tell you, I'm a mechanical engineer, but of course I have educational institutions, engineering institutions where I was teaching electrical engineering subjects and electronic engineering subjects apart from mechanical, and did a lot of research. And I'm a self-made man learning all these things. And after 2 decades of doing things like that, we started a company in 2015 to do something for the industries with all our expertise. And we have recruited experts from all fields like electronics, mechanical, electrical, computer science, etc. And to our good fortune, the first product automation solution we could provide was for Daimler bench trucks in Chennai, where their R&D plant was automated by us with pick-to-light solution. And we worked for all kinds of sensors that are available in the universe for 3 years. And all the data communications were checked with all the kinds of research possible. Later, of course, we did 3 of the manufacturing lines for Tata Hitachi. Flawlessly, they are working for the last 4 years. And then, of course, we did some raw material to packing everything, totally automating Denon food in Goa plant as well as in Bangalore. And then with that expertise, we have evolved today as a product development company. And then we have built 2 important products. Of course, this is being done because of our passion towards understanding things and understanding what the world needs today. And one of our product is Facttwin, which is for smart manufacturing, and the other product is for machine health monitoring based on condition monitoring using vibration analysis. I think I have given a detailed answer for your question.
We were expecting a very similar answer because, 3 years, 3 decades, that is 30 years of experience in R&D and number crunching and data crunching does that, sir. We completely agree. Fantastic, sir. Digital stage in our amazing stage is all yours, sir.
Thank you. Thank you very much. So, as all of us are aware, there are 4 fundamental things that are required to make any manufacturing process a smart manufacturing. The first being getting data in real time from all kinds of sensors, controllers, PCS, SCADA, and legacy machines where there are no sensors, what to do, go about it. So especially in Indian scenario where we come across all different kinds of levels of automation, and then we need different approaches based on different types of controllers, older controllers, a lot of bottlenecks are there even for data communication. And of course, mostly many of the implementation companies, what they do is they use third-party tools as far as data communication is concerned in many of the controllers. But at Akrivia, the great thing we achieved is that we could develop our own drivers which can interact and talk to any type of PLC of any type of make and model. That's what the last 4 years of research we succeeded. And the first most important part being the data that has to be communicated, captured from all types of machines and sensors, actuators, etc. And of course, when necessary from human entries also. And then once data has been captured, of course, the data processing has to happen. The data processing, of course, happens in the local server. Majority of the calculations happen on the local server, and whatever analytics are to be built, only that data will be pushed to cloud for further analysis so that all the web applications can be activated from cloud. Anybody from anywhere can view the data as per the roles and responsibilities. And then comes visualizing the data, both inside the plant and from anywhere outside. So all the possibilities, like any machine parameter, you can keep benchmarks for all types of parameters. Anything abnormal, immediately right from the operator, supervisor, based on rules, they get alerts, notifications, buzzers, everything is possible. And then, of course, all KPIs in real time, as expected by any smart manufacturing product, are available for everybody to view. And then, of course, from the cloud platform, you get all the machine learning, deep learning algorithms being built, and so that you can have analysis and analytics, including predictive and prescriptive as well, depending on the requirements of the companies. So we distributed this into 4 base. This is a basic automation product, and we have segregated into that. So I'm interested in telling the first part more about it, because we come across a lot of CNCs and PLCs, and of course, Siemens, Mitsubishi, to name some of them, lots of models are there, and we have to handle all of them with our own drivers without using any third-party tools. That's the biggest challenge we had, and we succeeded in that. So there is no license we have to pay to somebody else. We have our own drivers, and we have our own software platform, and we have our own implementation team. Every total solution is provided by one company, that's Akrivia. And now, as you're aware, a lot of protocols, some of them like MPI, Profibus, SmartBus, etc., with the communication channels, RS232, 485, Ethernet, etc. We have to handle all of them, and we are good at that. In doing so, we come across challenges like the port is free or open in each case. Then how to handle it? If it's free, if it's open, it's okay. Otherwise, how to handle it? Similarly, sometimes the parameter and all address registers are available with the company. The data is available, then it's very simple. If not available, then the program backup has to be there. If it's not there, then at least password is to be there, like the different challenges. And so we have to deal with case to case, machine to machine, we have to deal, how to handle it. Because this is not a new greenfield industry where all machines are of Siemens, same type. So n number of machinery we have to deal. And when it comes to testing quality devices, we have optical vision systems which take care of the quality. So we have to handle those controllers as well. So what we succeeded is we could capture the data, only reading data. We won't interfere, we won't give any instruction to any PLC, we won't control them. Whatever available on HMI, out of them, whatever parameters we have to capture, and whatever parameters are required for the calculation of KPIs, only those parameter addresses would be captured. And as you are aware, we come across DCS, SCADA. Of course, when DCS and SCADA is there, it's very easy to capture the data once there's a permission to connect to that. Communication protocol is enabled, then automatically the data will be captured. As I told you, we have our IoT gateways and all our drivers, what we have developed in so many years of research. We have all kinds of CNCs with us, all kinds of PLCs with us, and we have done all types of testing for years to see that whether the communication can be established or not. So we have our drivers which are located, depending on the type of machine and controller, our software will be loaded there. Every 3 to maximum 3 PLCs, one IoT gateway we put there, and corresponding drivers will be loaded. And the drivers will talk to the machines in real time, capture the data, and then do some validation checks there. And in case the network beyond the driver by any chance, the internal network, LAN network by any chance failed, even for a week's time, it's not necessary up to that extent. Generally, it will be down by 1 minute, 2 minutes, but the data will be stored there even for a week's time, and once network is established, immediately the data would be pushed. So data safety is also being considered there. And then going beyond that, one local server The local server, like Hariharan sir rightly given insights, most of the calculations happen locally, and the local server will take care of all calculations, and so that very quickly the alerts and notifications, including buzzers to the mobiles of all the maintenance team, will be handled by the local server itself, so there is no delay in the communication. And the local server also has the capacity to store the data even for a week's time, the raw data even for a week's time, so that in case of any network failure beyond that, the data is safe. So that local server only will need the internet. So all the encryptions, all the standard protocols available globally today are being followed there, and before going to cloud, all the encryption happens there, and then data is pushed to cloud. And of course, AWS, whatever safety features are there, all being used. And then, of course, from there, all the concerned from anywhere across the globe will be able to see their machines, how they are performing, their KPIs, their metrics, every analysis is available there for all them to see. As you're aware, there are legacy machines without any PLCs, older machines where they are not connected to PLC, so they may be having some sensors, at least to capture the brief data like machine start, machine stop, and regex or whatever it is. At least those kind of sensors are to be fixed. If they are already fixed, no problem. All such kind of legacy older machines, we cannot reject them because they are performing well and they are very costly. So we don't advise them to go for PLC for each one of them. Half a dozen to 10 such machines, we can configure one more PLC, and that PLC is only to capture the data from those machines, and that data would be again integrated to the mainstream. So this is how the entire capturing of the data from any kind of machine, any kind of sensor, actuator, or any system. For example, if they have their SAP working, any other ERP or MES, we also integrate with those things by API calling, and that is in fact as far as the information that is required, not taking every information from them. For example, scheduling of production, etc. we need. Such things we can call from them. At the same time, whatever final calculation, production details, etc., to avoid re-entry into their system, we can then make accessible that information to their SAP and post it there, so that all that integration together, they can save their time and they can have the KPIs calculated, being posted there, published there in real time. So this is about the basic architecture where we are using. And then of course, this is not a big thing, but quickly I want to run out because I can show it in real time with real-time data because time is only 20 minutes. So I thought of giving some screens here. Suppose I am the head of the enterprise, I have 10 facilities. So my interest would be how my all plants are performing today. So as a global head or enterprise head, I can have a sample dashboard like this, and I can have all the KPIs. Our product is not customizable. We won't customize it, but whatever you need, we have it there. We simply configure it. It's highly configurable. Company to company. Once this is configured to a continuous process industry, they feel this is done exclusively for them. It is good for batch production like pharma. It's good for discrete production like automotive. It can be configured for any kind of output they like. So KPIs are there. You can ask for any new KPI. You can have your own KPI specific to your company, and you can use your own formula for it. Even the formula for KPI, you can configure. Your admin can do it. It is made so configurable so that you can have whatever KPIs you like. Of course, the standard KPIs are already built into the system with all the standard formulae behind that, but of course, formula can be modified. But whichever KPI you want to have, but those parameters must be available from the controller. Otherwise, the KPI cannot be calculated. So whatever KPI is already a company is calculating, definitely they have the inputs for that, and all those inputs we capture directly from machines and sensors, and accordingly, the configuration would be done. Of course, the head of the enterprise can see how all the machines in all facilities are running now. This is only to have a brief information, not that they're going to act on it. If they feel generally OEE. If my OEE of 10 facilities is 80%, so I must be very happy for that. And of course, any plant across, you can select. If you select any one plant, for example, that plant will have The KPIs there, you can compare with the global KPIs and plant KPIs. So all such facilities are available. And instead of the map there at the center, you can ask for any KPI you like. Whatever analysis you like, that will be brought onto the center, and that the company itself can configure. Time to time, you can change whatever you want in the middle screen, whatever KPIs or other metrics or analysis you want to see. So this is about the global point of view. And similarly, role-based screens are being designed. A plant head can see only view of his plant. Sitting in his room, he can have the total idea of what my KPIs are, all machines together. Entire downtime of all machines together today as of now. Every minute it gets updated. Live data you can see. Similarly, performance. Of course, performance cannot be overall calculated. As you know, performance is individual machine-wise. So machine-wise performance is calculated, and all the average performance is being shown here, at least to have an overview, and quality, of course, total rejects and total good count, etc. And then availability, OEE. And they can have downtime reasons, and they can have batches. If they click batches, they can understand how many batches are going ahead of time, how many batches are lagging behind, how many are on time, like that information. From any of these dashboards, if you click OEE, it will take them into in-depth analysis of OEE. They can drill down, and finally, even the head of the enterprise can go down to any specific machine of any of his plants and go down and see what is happening in this machine in any 1 hour in any day. So he can drill down to 1 hour performance. In that 1 hour, how many stoppages, reasons for stoppages, OEE, availability, quality, etc., and so on and so forth. This is a lot of dashboards, like area manager will have the facility to see the machines under him. And whatever you're seeing here, this is highly configurable. Whenever a new employee comes, a manager, the manager should have access to what kind of things that your admin, the company's admin, can decide. They can modify it at any point of time, who needs to see what. Role-based, you can decide based on all the available features. Now, sometimes we need the operator's inputs or line manager or supervisor's input as well. Even though many of the alarms in most of the modern PLCs, we get from the PLC. Whenever a PLC or a controller stops a machine automatically, the PLC knows why it has stopped it. So the alarm is tagged, the register is tagged, so that without any human interference, we understand why the machine has stopped. Once the machine is stopped, for example, because of electrical breakdown, within seconds, the message goes to the electrical maintenance engineer, maintenance head also. You can configure escalations. The information has to first go to whom, and then has to go to whom, and so on and so forth. Role-based escalations are configurable. So once it goes to the maintenance engineer, within 3-4 seconds, it is logged. So people know when the message has been sent to him. The moment he will come to the machine, then he has to acknowledge it. Or wherever he is, he acknowledges from his mobile also, or from his tab. So people understand when he has acknowledged it. Other people come to know that so-and-so person is on the job. So no panic there. Everybody knows what is happening. And the moment he goes to the machine and then does something there and put it back on track, and the machine started running, then immediately he confirms that. Immediately people come to understand that maintenance fellow has done his job. In the next 10 minutes, suppose the machine is not started. Again, it is logged. Again, the operator has to take the responsibility. Machine has been put back on track at 10 p.m. Then why you have not started the machine at 10:30? That 30 minutes of downtime, if it is saved, the entire cost of our product will come with that 30 minutes. Even if 10 minutes of time is saved in a day because of these minor stoppages, which are less than a minute even, that 10-minute stoppage will give the return of investment for the entire product. That is the beauty of this particular product. So in case of the stoppages, if the operator stopped the machine and the controller doesn't know why he stopped it, in such a case, operator has to give some inputs. In such cases, for critical machines, industrial tabs will be fixed near the operator, near the machine, so that all the stoppage reasons, unplanned, planned, etc., would be configured. They may change from machine to machine. All machines need not have the similar stoppages. You can configure whatever stoppages that are occurring, that are expected. In future, you can add one more stoppage or modify it, edit it also. So operator needs to simply, the moment you stop the machine, in the next few minutes, anytime, need not be immediately, you can just touch that so that the message goes to all the people. Stoppage message immediately goes, but the reason also goes. So these reasons also are important for analyzing the root cause for any particular stoppage. Sometimes, and mostly, operators doesn't like to do all this job. They are not interested, practically. So in such a case, the supervisor can have a mobile tab. On it, all the machines under his control will be there. Any machine stopped and operator has not given the reason, again a pop-up comes there. So he can go near the machine and he can do it from his tab, or he can do it from the operator's tab, he can do it from his mobile, or he can come back and do it from desktop. Or sometimes if operator has given a wrong reason, by mistake he has given a wrong reason, then supervisor or higher manager will have a chance to edit it. But when he edits the reason for stoppage, the original reason given by the operator will be intact. And whoever edited it, what addition he has given, and he has to write the remarks as well so that transparency is maintained. And bulk edit is also possible. By mistake, the shift ended and he has gone, so in the next shift he can come and edit it with proper remarks. So everything is transparent and everybody is accountable. Similarly, this kind of dashboard will be available for the quality people. Different types of quality systems are there. Manual physical examination. Somebody is there picking up the bottle in the filling station and saying cap is not there, like that. Then you'll have a tab to check. One part is taken, rejected because cap not fitted. So just touching that, manual entry goes there. If there is a vision system which is automatic, then we capture from the data from the controller of the vision system and automatically the quality goes there. If you have software for your quality, already you are entering the data there. We integrate with that and get the quality data from there, and then that gets integrated into our system. Ultimately, the purpose is that the quality parameters are also required for the calculation of OEE. So this is about brief, and we cannot expect, especially in auto parts industry, we cannot expect the supervisors or other people to sit and cling to their desktops. They'll be on the move. So when people are on the move, as you're expected, and most of you know about it, big screens you can have at all places in a grid format or end-on screens. Any machine down, it goes to red. Not only saying it's red, you can have the important KPIs, either OEE or whatever it is, you can have it there. So people on the move can see how good my shop floor is, my area is. Area manager will be very happy to see how the things are happening. It's not only that, it also gives a trend. Not only is green just is not good. It is green, but its trend is coming down. That means performance is going down, OE is going down. So they have to react. So the brief important KPIs can also be seen there. So this kind of all information with real-time data, with just few seconds lag, will be available for all the concerned. And the most important one is view machines, right from the head of the enterprise to the operator or to the supervisor. Whichever machines they are eligible to see, all of them will be coming. This is, of course, a standard way. You have overview of running and stoppage status, etc. And important KPIs, how long the batch has been running, how long the machine was running without stoppage, and what is the part production, is it going on time or lagging behind. So any machine you find that something is not going good, then if with a single click on that, you'll get the entire story of the machine for today. You can see the machine for today, you can see the machine for the current batch, you can see the machine for current shift as well by selecting the current filters. And this is the timeline. When the batch started, green is running. If you mouse over here, you'll get a pop-up which shows that how many parts are produced during that continuous run. If you mouse over here, it will tell what is the reason for the stoppage. Again, running, stoppage, duration from when to when. And you also have the stoppages classified here. And which stoppage is happening how many times. You can configure yourself that if any stoppage is more than 10 minutes, you want to get an alarm. Who has to get the alarm? Who has to get the escalation? All those things are configurable. We won't customize it. They are built into the system. And then comes KPIs. Here comes the important parameters. Machine to machine, the critical parameters, what you want to observe are here. If you click temperature, the temperature trend will come. If you click two of them, the comparative graph will come which will tell how one increment in one parameter is influencing the other parameter. The maintenance people can study how their interrelations are happening. This is only an example. You can have tens and hundreds of parameters here. They are live. You can have the average parameters for the day. You can have the average parameter per shift, and you can have the live parameter as well. And you can have the KPIs also there. Whatever KPIs you like in real time, they get updated. Any KPI less than your benchmark, automatic notifications, alert buzzes will come. And this is one example where I have selected temperature and pressure for the last 30 minutes, how the temperature and pressure related to one another. Because in critical machinery, the temperature parameter being abnormal will influence the quality as well. Similarly, you can go for availability, how availability is changing, how performance is changing. You can see any parameter influencing KPI as well. All that real time you can be studying here. But if you want to study last 1 month, what happened, last 30 days, they're available in analysis. Here, this is for real-time data. Right now, what is happening in my manufacturing facility. Now, this is, of course, performance batches. This is very important. I call it batches here. It can be configured for lines, depending on the type of manufacturing. So you have all the batches running here. Any one batch you select, within half a second, you get the entire process KPIs right now. And then what is the ideal cycle time, what is the actual cycle time, what is the average cycle time. If it is a manufacturing like a capsule, if it is a pharma industry, then in how much time you are expecting to complete the batch production if it runs at this rate. If it's performing like this, how much delay is expected. You can configure alarms for all the batches which are having delay more than 30 minutes. Automatic, everything will come as per your requirement. So any batch, you can also configure such that the worst performing batch will come always to the top. You need not search for 20 batches or 20 lines. The worst batch is always at the top, the lowest, the poorest performing batch otherwise will be at the top so that you can just select and see. This is for understanding the manufacturing process in real time so that we have to take very aggressive and quick reactive procedures so that we can solve it immediately. And the most important thing, as you're aware in Industry 4.0 is everything is transparent, right from the CXO to the operator. Everybody sees the same information, so nothing to hide, so people become more accountable and things happen automatically. In a month's time, but the moment we start implementing the product, by the time we finish it, people notice that there is a lot of improvement. The ROI comes by the time our implementation gets completed, because people come to see about it. What is happening? In my machine, I have, I think, 5 minutes? Okay. Oh, I'll quickly go through it, sorry. So I'll skip all these things. A lot of analysis is available. You can have all the analysis. You can have KPI analysis, all types of KPIs. You can have OE analysis, you can have downtime analysis, you can have machine usage analysis, all can be tabulated, and batch analysis. Most important, you can have wastage analysis, how much electrical energy is wasted, all such kind of things. And then you can have maintenance analysis, OE and analytics, and most important, root cause analysis. All the 5 analysis tool as well as fishbone analysis tool is built into the system. You can design your own primary causes. And people sitting at different places can communicate and have the analysis being done online. And you have statistical process controls. If you have your quality data automatically coming from your controller, then any process or any parameter out of control, automatically any chart, X bar R chart, any chart gets automatically generated and you can have it. And reports are highly configurable. You can ask for any report you like. Downtime report, day-wise, month-wise. In real time, you can get reports. Unfortunately, my time has run out. So I have, in fact, I thought of telling you about my second product. Maybe I'll take some other opportunity to go through that. It will take another 7-8 minutes. This is regarding vibration analysis. We have our own patented sensors where the triaxial accelerometers are put into that, and then in real time, the vibration data would be captured and then analyzed, fast Fourier transform is done, and then you can have your machines, like how many of your machines right now are having gearbox issues, how many are having misalignments. It's not just capturing vibration after analyzing fast Fourier spectrum analysis, which vibration is having a peak, and this peak is because of unbalance, because all the technical data has been entered in the system, like if a motor is there, if it's a gear driven, then how many teeth are there in each gear wheel, what is the shaft speed of the gearbox, belt, if it's belt length is how much, pinion radius how much, all the technical details are given, and as if it is a expert in condition monitoring. Vibration analysis certified expert, how will do? Like a doctor will see a scan, MRI scan and do that. Similarly, all the functionality of thousands of bearings that are available in the market, if a bearing of so-and-so model is defective, then what peak comes, all that knowledge has been built into the system. That is why you can have a real-time view of X, Y, Z vibration, and then you can have the trend of vibration, you can have the trend of unbalance, etc. Yeah. So I thank you very much. Hope I have not disappointed you. I'll take another opportunity to talk about my other product. Thank you very much for your time.